Section 3.3, problem number 12. It's talking about increasing and decreasing. It can, so what it's talking about is increasing means from where to where is the graph going up. Okay, so on these you've got to know that your endpoints are continuing forever, right? So you're looking for transition points. And what I call transition points are like mountains or valleys. Okay. So this transition, here's a transition point. So we'll bring that down. We'll come down here, it transitions here. So we'll go there. We'll put negative infinity out here, and we'll put infinity, positive infinity on this side. Now, it says from where to where is the function f increasing. Well, what I tend to do is this. That kind of makes it a little bit easier for you. Is negative infinity, -3, 3, and positive infinity. So if you're looking from left to right as you're reading the graph, you picture a person. This person is walking up this graph to this point, right? And at this point, the x value is -3. So he walked uphill, or increasing, right, from negative infinity to -3. Now, from -3 to 3, he's going to be walking down, right? And then from 3 on to infinity, he'll be walking up, which is increasing. So it says, give me the intervals for which the graph of the function is increasing or decreasing, right? Well, you basically telling a story about the x-axis, and you got to make sure you understand it's about the x-axis, right? It's not about the y values. Note that every transition point where it changed direction, I brought it back to the x-axis because that's the point that I want to reference. Now, so once I do this, then it's very simple to know where's it increasing. Well, it's increasing from negative infinity to -3. And then 3 to infinity, right? There's a break here because it's going down, it's decreasing, it's not going up during this point, right? So sometimes I teach it on the graphs themselves. So I'm going up, I'm going down, I'm going up, right? So the decreasing would be from -3 to 3, and they would be parentheses. The reason they would be parentheses is because at this point that we're looking at, it is not it's not decreasing nor is it increasing. It's a transition point. Okay, so just kind of got to be aware of that. All right, so that takes care of increasing and decreasing. You're telling a story about the x-axis. A good example that I use is if I said, hey, let's go to Myrtle Beach. right? It's 5.5 hours. It's about 200 something, a little less than 300 miles to get to Myrtle Beach. Um, but when we think about that, we think about line of sight. We don't think about being on I-20 and having to go uphill and downhill and all that other stuff. So you're telling a story about the x-axis, no matter if it's going up, what your y values are doing per se, as during that point. Now, the y values do come into play when you're talking about maximums and minimums, and they come into play to find the transition points, that it's transitioning at this point and at that point, which we came down and tied back into an x value, right? Where in the input is it happening? Where on the x is it happening? Okay. Now, the notes for this section, when you go through it and you look at it, it says local maximum, minimum. Maximums are mountaintops, right? So that is a maximum, okay? It's not the highest point of the graph because the graph continues to go over here on the right-hand side, but it is still a maximum, okay? Because if you stood right here and you look left, you look right, I don't see anything to the left, but if I look right, I can see that the graph is going on. That's going to make it a local, okay? You can have an absolute or local, maximum or minimum, right? Absolute is final, right? It'd be like the highest peak. There's nothing to the left or to the right of you, right? Not -3, 4. It's 54, right? -3, 54. Yeah, it's a point. Yeah, that's correct. So ordered pair. Mm-hmm. Yeah, and then this one here would be a minimum, right? For mine, it's 3 uh, and -54, right? Yeah, depending upon what you're looking at, just make sure you're pulling that ordered pair right there. Okay. At the maximums and the minimums, those are going to be your transition points. So that's going to help you see where to move things to the x-axis and everything. So let's see if we've got another one here. If you see what y'all can do on this one. Okay. That was number, what I say, 15, 12. Yep. All right. So let's see 13. All right. 13 is just increasing, decreasing. So I'm just going to grab half the graph since it's just, only that. And then I'll also grab this. There we go. So like, yeah, like for this one, okay, it's still going here, right? So what I need for you to do is for you to determine what you think the interval of increasing and decreasing is real quick, okay, for this particular problem. So what I'll do is I'll pause it and I'll give you about 30, 45 seconds to see what you can do, okay? There you go. So what did you get for increasing? It would be -2 to infinity, right? Yeah, like if you draw it here, it's negative infinity, positive infinity. You got your line. You're going down here and you're going up here. So it's decreasing from negative infinity all the way to -2. Fair enough? All right. Tiffany, how'd you do on that one? On the increasing and decreasing, you shouldn't be using the brackets. They should just be parentheses. We have used, I can't remember if it's the software that we used in 1101 that for some odd reason they used brackets. It's just like the mathematical community itself is standard that there's really, it's not increasing nor is it decreasing right there. So how can you put a definitive spot? So unless it's an endpoint uh, or something like that, then I can see that, but not a transition point. Would this be a maximum here or a minimum? What would its value be? There you go. So they can ask you, they can ask you, say, okay, minimum, and they can give you an ordered pair, which would just say, okay, you fill that in, right? Because it's right there, -2, 1. Sometimes you may see it say minimum, and they're just saying is equal to 1, right? They're just giving a a y value. So yeah, so the two ways here are are traditionally how you'll see it. They either give you, excuse me, an ordered pair, X, Y is an acceptable answer. Or if they don't set it up as an X, Y, if they just say what's the minimum, then they're wanting the Y value, right? So just kind of make sure you understand that. Okay. Um, let's see what number 14 has. 14, they would have brackets at -3 and 4. Okay. See how those are endpoints here? Well, you can't see it because I haven't moved it over there to you. So hold up. Let me show you what this one looks like. This is number 14. See how they got endpoints? They should, yeah, they should use the brackets. Um, it's included. Brackets means it's included. For increasing, that's what I'm saying. From -3 to 1, and then decreasing would be from 1 to 4 for this one. That's what I'm saying because of the endpoints. No, we're on number 14. Yours is different than mine. See, everybody has the same type of question, but different numbers. So, yeah, for the endpoint ones like this, it should be a bracket. Um, I guess I can type it in, see what it does. So should do it -3 comma. Well, I started that. Shoot. Um, uh, be mindful of that because they're not wanting. I would put the brackets just from that, and um, so whoever textbooks that they used on this one, they chose to do that route, but they're wanting the green, so they're not wanting the brackets themselves. They just want parentheses period on those. Huh? The absolute maximum, think about a mountaintop. So if we draw a little man and we put him on the mountaintop, and he looks left and right and doesn't see anything that's above him, then that would be an absolute. Um, that would be an absolute maximum. I just explained. If I were to answer this, if I were doing the problems and everything from a textbook, I would put brackets because of a defined point there. But this textbook is saying, and we're not, there's two ways that you can do that. Depends on what textbook you look at. They're using parentheses throughout, so you ain't got to worry about it. And absolute maximum for this would be 1 comma 2. Well, do you see a well for this one? It should be a valley, right? This one, the absolute minimum would be that point, -3, -2. So yeah, for the endpoints, if it's doesn't do like the other one, like a valley, and it just has these points like this, then that would be the lowest point on it. Yeah. Yeah. And it's this -3, -2 right here. And the reason being is right there. See, it's got a, the graph is not going on forever. So we've got a defined point within that graph that we're determining mins, max, increasing, decreasing. That would be slope. That's a big word for slope. So what we'll do is, you're probably looking at the first ones, right? All right. Mine says from 0 to 4. But I'll show you on mine real quick. Uh, and then you can be able to see it to do what you got to do. It says find the absolute from, let's see, 0. Yeah. Okay. There it is. All right. So basically what you're doing is, these are X values. So at 0, what's your Y value at 0? 0. At 4, what's your Y value? Negative 128. So there's your ordered pair, right? These are basically ordered pairs. And then you could do y2 minus y1 over x2 minus x1, right? Or you can, I know that this is changing x and this is changing y. It's going down by 4. From 0 to 4, it's going down by 4. From this one's, it's going down to negative 128. So slope would be changing y over changing x, which is negative 128 over negative 4. And I don't have a calculator in here, but that should go into 32 times, right? Yeah, so that would be your rate of change. That'd be slope. And really it'd be 32 over 1, but since its denominator is 1, we just say 32, right? So that's pulling it from a graph. The other way that they can do it, and that's from this question, and it's let's see, it's question number 2, is they can pull it from an equation. Okay, so with them pulling it from an equation, they're saying find the rate of change on this equation from negative 4 to 4. Well, these are x values. So what you have to do, the first thing you have to do is you have to plug in um, and solve for the output, right? Interval notation. Yeah, that's part of huh? Oh yeah, I'm about to do this, but it says the rest of it says for the following exercise, find the average rate of change for the function on the interval specified. And when they talk about an interval, they're talking about the same things. Interval notation is talking about the same set of values. Yeah, that's right. You're exactly right. So this would be 4. So this is 4 minus 2 times 16. So 4 minus 32, which is negative 28, right? And then this one, I'd take this, because these are x values, right? Because it's intervals. It's not an ordered pair, right? Yep. Um, ooh, that's the same thing, right? Yeah. Hmm. Yeah. So what would be the rate of change on this? Well, that would be from negative 4. If you look at that as changing x, that's changing y. That from -4 to 4, that'd be a change of +8, right? And then here, it'd be a change of 0. Which is what? 0. That's right. There you go. And that's really all you're doing, right? So that's the first two problems. There's 3 and 4, and I'm pretty sure I'll look at it. And look at it 3 and 4, 3, 4, and 5. 3 is exactly the same as this. It's an equation. 4 is a table, right? Ordered pairs that you're pulling. And then 5 would be, let's do 5 because that's probably your harder one of them. Just because it's a word problem. That burn it. All right, so surface of a planet far away, the distance an object falls is a function of time. It's given by dc equals 4.333 t squared, where t is in seconds, and d sub t, which is the outputs in feet. If an object's dropped from a certain height, find its average velocity when t is equal to 1 and t is equal to 3. So basically, t is equal to 1 and te is equal to 3, right? So we'd go, here's your x values. You'd have to plug them in, right? How many of those? 4. So the first one would be 4.33, and then the second one would be 3 squared, so it'd be 9 times that, and I'm not sure what 9 times that is. I don't have a calculator with me. All right, you got what now? Okay, so then you're just, here's your 2 points. You're just finding slope. That's it. So you know your change in x is going to be a 2, right? So 38.9997 minus 40, or it's a change in, I don't know, however far that is. I would probably, for this one, I probably wouldn't do it just because it's not nice, pretty numbers. I probably wouldn't do it as that. I'd just do y2 minus y1 over x2 minus x1. That way you've got, you'd have less confusion. You'd be, you'd be a little bit better on what you got here, okay? Yeah, these are identical. These are the problems from the homework. No, the notes that I work or do is only a portion of the problems in the homework to teach the content. The notes that I do are not every problem in the homework. Yeah, I mean, I can't. Well, it's a rate of change, average rate. It's a slope problem. You got to evaluate it, then you find your x and y. What gave you your x's, you just had to find your y's, then find slope, and you're done. That's really what the first 5 problems are like that. And then the last ones are increase and decrease in maximum minimums. Okay. So that's, you know, if we had enough time to had enough face-to-face time in class, uh, this portion of it would have been brought up of, okay, hey, you didn't work a problem like that. Well, no, I didn't work a problem exactly like that, but I worked a problem that has content that is the same as that. Yeah, that's the whole portion of uh, why I'm using the homework on my blank teaching notes to teach the content, so that one, you're seeing stuff that you're going to see again. Two, you're learning content, as opposed to me just saying, here's some random problem. Let's teach the content, and then you've got to figure out how to put it or apply it to the homework. So that's why, uh, those videos of the lecture videos are, they're not going to cover every problem. You know, it's not going to cover every problem that's on the uh, in the homework, but it's going to give you an opportunity to be exposed to content so you can work the problems that you need to. What's got you on 4? Those are ordered pairs. You're just, yeah, let me look right here. Let me show you what I'm looking at, and then we'll be on the same page. Um, if I here it says find the average rate of change for 2001, 2003, right? There's an ordered pair and there's an ordered pair. Yeah. And then the next problem says, oh, 2001, 2005. Well, I'd use that same ordered pair, and then here's the other pair that I would use to find my other rate of change, right? So, and then 2003. Boy, I wrote that wrong there, didn't I? 244. And then this one would be 2001, comma 236, and then 2005, comma 236. So you have a change in y 0, right? This is 4, so you have 0 or 4, which is 0, right? For mine there. So that one would be 0. And you just, you can do, what I'm doing to change an x and change y, as long as you know that if the number's going up, it's positive. If the number's going down, it's negative, and then make it applicable signs over here. Or you can just use the y2 minus y1 over x2 minus x1. Yeah, those are still, doable. All right. So I'll go back and look at Bruno had to